We have the question Game of Life that was in the Deltix round spring 2021 for Division 1 and Division 2, and this was conducted yesterday. And this was the first question, so it's basically just about some computation. And so the question states that a person, William, really likes the server automation called Game of Life, so he decided to make his own version. For simplicity, he decided to define his own circular automation on an array containing n cells, with each cell either being dead or alive. So, evolution in the array in Williams cellular automation occurs in the following way. If the element is dead and has exactly one alive neighbor in the current state of the array, then on the next iteration it will become alive. For an element at an index I, then neighbors would be the elements with the index I minus 1 and I plus 1. If there are no element at the index, it is considered to be a dead neighbor. So also William is an main person, so all the alive elements remain alive. So if an element is already one, it will never change to zero and it will remain one. So we are given some initial state of the elements and we need to find that state of the array after m iterations of the evolution. So we are given some input in the form of an array, a string basically, and we want to see that after some number of iterations, like in this case 3 iterations, what will be the state, like shown over here. And according to the rule given over here, where each iteration does this thing on every element. And so So the input will be given in the form of number of tests we need to run and the size of each string array and the number of iterations we need to perform and give the final state. So let's head on to the logic first. So the logic of this question is really simple. So there are just three cases to be mentioned, and these are, so let this point be the start of the array. So this is the start of the array, and we have some n number of zeros before the first one. So these are n number of zeros before the first one. So these are n number of zeros, and basically we need to perform m iterations on this end, as also as no other value after the first one would ever affect any of these zeros. We don't need to consider any other element for these zeros. So for this we see that the number of iterations is m, and also we are given that if any dead cell, that is any cell which is zero at some point, has an has exactly one alive number, we must change it to one. So basically the dead cell goes to alive cell if exactly one of its neighbor is alive. So initially none of the neighbors of on the first iteration, none of the neighbors of the first n minus 1 zeros is alive. So these zeros won't change in the first iteration, and only this zero with the last zero occurring over here, this zero will change because it has exactly one alive number, and it does not matter if n is equal to 1 or n is greater than 1. So in any case this will go to being alive in the first iteration. So similarly, on the second iteration, the zero next to this and the zero next to that will go on getting alive, and this will occur up to m zeros if m is less than or equal to n, and maximum to maximum n zeros if m is greater than or equal to 1. So this condition, and after this we need to head on to check for the intermediate value. So intermediate will be something like intermediate values will be something like this. So these are n, so these are n number of zeros, and we need to perform m number of iterations. So basically similarly as we did for the starting of the array, we have this cell whose only one neighbor is alive, so this will go to being alive. Similarly with this, these both cells will go to being alive in the first iteration, and similarly so on. Now here some another two more cases come in which one of these n mod 2 equal to 1. So when n is not divisible by 2, or the remainder of n divided by 2 is 1, the middlemost element will never go to 1, because when, let's say, after some iterations, both the elements to the right and to the left are 1 for this element. As we need exactly one alive element for this element to being alive, this element won't go to being alive for any iteration. So, and if n is divisible by 2, or remainder with 2 is 0, we don't need to worry for any specific 0 on, nor the middle 0, or nor any other 0, because none of the cells will ever have exactly two alive numbers, other than the case when it's already alive. So yeah, basically this happens, and in this case also, we have a maximum of m iterations. So either the maximum number of values turning to one from the left hand side will be m, or n, or n by two, depending on the number. So, and for the final case, which is the last. So last. So the last, for this ending of the array, let's see, we have and zeros, and we have m iterations. So and zeros and m iterations, this is basically the mirror case of the starting case. So in this case, on the first iteration, this zero this first zero will go to being alive, and on the second iteration, if it occurs, then the second zero will go on to being alive, and so on, until maximum of m, and maximum of m comma n iterations. So basically, this is the logic for the same, and let's head on to the code. So the code is really simple. Basically, we take two input numbers where the numbers are n and m, and we take an input string with only elements as 0 and 1 as character, and for each, for we iterate along the array, and for each value we check, like in this case, we have checked str equal to, like if the element is alive, then we check if the previous element is at -1. So initially, the last element which is alive is can be said to be -1, as no other element is no other element is alive till now, and this is just a check condition. If the initial element is this, then we have go on to change maximum of m and n iterations to the first m elements to 1. And for the intermediate stage, this is the code. So we change from the starting and from the end, and this condition where j is less than equal to this divided by half already takes care of the even and odd case. And for the last case, this iteration won't give us the last for the end of the array, and for that we need to make an extra iteration and check which is the last element, which is 1. And for that, if we get the element which is equal to 1, we change at maximum of m comma n iterations to the right of that to 1. So then we print the array. So as you can see, after we run this, we get this output. So this is working fine. So let's change one of the inputs. So 10100, and we are given two iterations, so this won't go to 1, and these both should go to 1. So let us see if our code works correctly. So yeah, 10111, that's the required output. So let's see if our code is accepted. Oh, so we can clearly see that our code is accepted. Thanks a lot.